Okay, this video is to go over your homework from the previous night. You got to do page 182 through 183, 24 through 40 all. Here are the answers to 24 through 29. I'm not going to work them out in great detail, but in some detail to show you what you should have done and how you would have arrived at them. So 24, you had two parallel lines crossed by a transversal, and you know they're parallel because of the markings on them. So you saw arrows here and here. And we knew this angle is 114. We know this angle is y degrees, and this angle is x plus 12. So these angles are corresponding, so they're congruent, which is where that came from. And then this forms a linear pair. So these two angles are supplementary. So add them together equal to 180, and then solve for x, which is where this guy came from. For number 25, again, it's very similar. You had parallel lines crossed by transversal with a given angle measure here and angles here and here. So these guys correspond here and here. So 3x minus 15 equals 105. So I'm going to add the 15 over. It gives me 3x equals 120. So x equals 40, which is what we got right there. And then this is a linear pair, so that means this equals 75. Subtract the 25, you get y equals 50. See how much easier the odd problems are than the even? Aren't you guys lucky you get to do the even ones usually and not the odds? All right, 26. Let's see what we got. We have a pair of parallel lines crossed by a transversal. This is 2x degrees, and this is 54 degrees. And we couldn't do this problem without those being parallel. So I'll use corresponding angles to get this to be 54 degrees. Linear pair. So 2x equals 126. So x is equal to 63. Just like we got right there. Oh, wow. Threw that guy away. Cool. All right. Number 27 looked. Here we have a... Don't see the one I want. There it is. You want that. So we have some sort of trapezoid. We'll learn more about trapezoids later. Trapezoids are quadrilaterals that have exactly one set of parallel sides. So here's our trapezoid with angle measures 96 degrees, 94 degrees, 2x degrees, and 3y plus 44 degrees. So the trick is you have, well, it's not a trick, but let's see. Here we go. You've got these parallel lines crossed by this transversal. So your your consecutive interior angles are supplementary. So 2x plus 96 equals 180. Do a little subtraction, do a little division. You get x equals 42. And you have these parallel lines. There we go, I want a different color. You have these parallel lines crossed by this transversal. So consecutive interior are again supplementary. So you're going to add those two together, let them equal 180, and you should get y equals 14. Uh, 28, the same thing. We have another trapezoid. So it has exactly one set of parallel lines. Here and here, but also this line keeps going. Oops, this one keeps going. Oh, actually, I'm doing 29, and I'm not going to erase it. So you are looking at 29. Alert, 29, alert. This is 3x minus 70. And this is 3y plus 40. And this is 120. And x degrees. So I have parallel lines crossed by this transversal. So consecutive interior angles are supplementary. That means that x is 60. Now if you try to set these two equal, that's not good, because this line and this line are not parallel. So alternate interior angles are not congruent. So if you got x equals 30, or no, 35, that's what went wrong. X is 60. So plug your value in for x. That's 180, that's 110, that gives you 70. So then you subtract, and then you divide, and you get y equals 10. And 28 works the same way, so I won't go back and do it in the interest of time. And then you can pause and rewind if you have any questions. Next, you're given the m. 1 second. So we're given that m is parallel to n, and we're given that L is a transversal. And so what we want to do is prove that angles 1 and 2 are supplementary, and angle 3 and angle 4 are supplementary. So basically this is just a proof of the consecutive interior angles theorem. So the way we attack this, I always want to do our diagram first, so then I added my parallelness to those, is we want to use the postulate. Oh, wait a second, we're not doing this from scratch, so this is fill in the blank. So if I were going to do this from scratch, I would say they're parallel. Then I would say that 7 and 1 are supplementary because they're a linear pair. 7 and 2 are congruent because they're corresponding, so 7 and 1 are supplementary because they are congruent angles. But let's see. For B, it just tells us that angle 1 and angle 3 form a linear pair, and so that's what linear pairs are, so it's the definition of a linear pair. And C, you have to come up with all your own. But they say if two angles form a linear pair, then they are supplementary. So you would say that angle 1 and angle 3 are supplementary because in B we name them as linear pairs, and angle 3 and angle 4 are supplementary because again in B we name them as linear pairs. Alright, now we have to look at the picture a little bit, because what they tell me is that angles 1 and 4 are congruent. There's 1, there's 4. Angle 2 and angle 3 are congruent. So what I said before was that I was going to go with corresponding angles congruent. Well, these guys aren't corresponding, so the book went a different direction. The book went with alternate interior angles. So I don't write alternate interior angles theorem, I write alternate interior angles are congruent, so that I later on don't have to remember if it was a theorem or postulate. E was all good for us. F we should never miss because it's the last statement in a proof, so it should be what you're trying to prove, which is that stuff. Angles 1 and angle 2 are supplementary, angle 3 and angle 4 are supplementary, and then you need the reason, and we just did substitution. Alright, let's look at the next one. Here are the answers to 31 through 34. And while you are checking those, I'm going to sketch it real fast so we can see what the question was about. You just check yours, don't bother what I'm doing. Don't look over here, nothing to see. Alright, that's basically what it looks like. And then let's add the other stuff. It looks like all of these are parallel. And these are parallel. And I've got some right angles. And more right angles. Yikes. I got lots of right angles. And I've got some angle numbers. 1 and 2. 3 and 4. 5 and 6. 7 and 8. That's not my best 6. Oh, okay, that's not bad. And then, here are the questions. Question 31 said angle 1 and angle 8. Here's 1, here's 8. So, let's get the old magic pen out. So, it will erase. Let's give it a different color so we can see it better. Alright, so, we've got parallel lines here. Crossed by this transversal. Whenever you can make a Z like that, then you know you have congruent angles. So angle 1 and angle 8 are congruent because they're alternate interior. Number 32 is angle 1 and angle 5. Here's angle 1, angle 5. So you've got parallel lines crossed by this transversal. So the corresponding angles are congruent. So angle 1 and angle 5 are congruent. Number 33 is angle 3 and angle 6. Now this is where my picture is not the bestest in the world. All of these lines should have intersected at a single point. And then 3 and 6 are going to be vertical. And vertical angles are congruent. Number 34 is angle 1 and angle 2. Here's 1 and angle 2. So this time I have a right angle box. Oh, you gotta love the magic pen. I have a right angle box. And so that means that these angles add up to 90. And angles that add up to 90 we call complementary. So that was not a bad problem set. You can rewind it if you want to see it again. It was pretty entertaining. Alright, 35, we want to prove the alternate exterior angles theorem. So we're going to do this one fairly quickly. We talked about it in class. When you're proving theorems, you should look in the book and copy their picture. But I'm not going to do that. I am just going to make up my own angle set. I'm going to call this line A, this line B. I'm going to give myself some angles. Here's 1, 2, and 3. So basically you're given A is parallel to B. Oh, don't follow me around. Alright. Then angle 1 is congruent to angle 2 because corresponding angles are congruent. And remember, that was the postulate that we don't have to prove, and so that's why I always go back to that when I'm proving theorems. This is a 3. Angle 2 is congruent to angle 3. That's our good friend vertical angles. That says vertical angles are congruent, trust me. And then look at the order, we actually did it really nicely. So we shouldn't sound surprised. Angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, which means angle 1 and angle 3 are congruent. So this set up perfectly for the transitive property. So angle 1 congruent to angle 3, transitive property. And we're done with that one. Okay, next. 36. Here are the questions and the picture. Let me draw it real fast. Okay, it's probably not going to be real fast, but it won't take too long. Yeah, it looks like that, and I've got 1, 2, 3. Looks like 4 squares in there. So let's divide it in half, and half, and then half, or close enough. And then you just have these braces, maybe. Oh, goodness, 1 second. Someone's at the door. And we're back. So let's number these angles. It looks like we have 1, 2, right angle, 3, 4, right angle, 5, 6, right angles, 7, 8, 9, and 10, 11, and 12. These guys are all perpendicular, so I'm going to stop putting the right angles in on a count of time. 15 and 16. All right. So let's look at the questions. How are the odd angles related? Here's 1 and 3, 5 and 7, 9, 11. So you've got parallel lines crossed by a transversal and several transversals. So the alternate interior angles are congruent. So they would be congruent. How are the even ones related? This time you've got parallel lines crossed by a transversal. Let's do this one over here. Put that parallel line in, such that alternate angles are congruent. All right, and then if you take an even with an odd, and even with an odd, since they're all congruent, then they are going to add up to 90 degrees. So those guys are complementary. And what term for the two roadways? They're parallel. Next. Just kidding. Next. Really next. There we go. Prove that if a line is perpendicular to one of two parallel lines, it is perpendicular to the other one. So there was, again, when you're doing these proofs of theorems, then you need to look at the picture in the book to copy your picture. In the interest of time, I'm just making mine up. Here, we'll call this one A, we'll call this one B, we'll call this one 1, call this one 2, and what I would be given, we'll just rewrite that, is that A is parallel to B, and we need another name. How about C? And that C is perpendicular to A. We would want to prove that C is perpendicular to B. So what I would do is say, since A is perpendicular to C, that means angle 1 is a right angle. That's what perpendicular lines do, is they form right angles. I would say angle 1 is congruent to angle 2. Corresponding angles are congruent. And here's a good one. I don't think we've talked about it, so maybe next time we see each other we should talk about it. But angle 1 is congruent to angle 2. We said, whoops, what I wanted to say is that angle 2 is a right angle. Oops, okay. And that's because all right angles are congruent. That's a nifty theorem that we probably wrote down sometime, but it comes in handy sometimes, saves you a step here and there. So that means that C is perpendicular to B because that's what perpendicular lines do. They formed a right angle. Whoops. Gotta stop hitting that button. Okay, and then if you look in the book, in the back of the book, to check yours, you would see they did it slightly different. And that's why I like that little theorem right there. Save me a step or two. All right, let's finish this up. Uh-oh. scrolling thing is never good. There we go. The answer to 38 is x is 22. Answer to 39, x is 130. Let's look real quick at how we got those. Now this is a bit of a twist on the one that we've done in class yesterday, in as much as you have the one that's in the middle and you're trying to get one on the outside. This is x degrees, this is 72 degrees, and this is 50 degrees. So I think the fastest way to do it would be to construct a parallel line parallel to the other two. And now if this part of it's 50, and corresponding angles are congruent, so that's 50. 50 minus, or 72 minus 50 is 22. And then these guys are corresponding, so x is 22 degrees, which is what we said right there. Let's get rid of some of this stuff. Well, how about all of it? Alright, now I've got another parallel lines. And I've got that going there, and that going there. And this is 105. This is x degrees. This is 125. So let's do the third line parallel. So if this is 105, this is 105. Start again. If this angle is 105, then this angle is 105 because they correspond, and linear pair makes that 75 degrees. And if this angle is 125, then this angle is 125, and that makes this 55 degrees. And if I add 55 and 75, I get 130, which is what we said it was. You do have one of those in the quizzes today, so rewatch those if you need to. Alright, you can look at the answers to these while I draw the quick picture, and we can talk about it. We'll go with dotted lines. Didn't really plan on it. And let's see, you got a 7, 8, 6, and 5, 3, and 4, and 2, and 1. So the question for 40 part A said, how many possible angle pairings are there? Alright, there are 28. You can match angle 8 up with 7 different angles. You can match angle, then starting with 7, you're down to 6. And starting with 6, you're down to 5, and so forth and so on. And when you add the 7 to the 6 to the 5 to the 4 to the 3 to the 2, you come out with 28. Now, since these lines are parallel, if you choose any angle pair, there's only two possibilities. Either the angles are going to be congruent, like 7, 3. Oh, this is a 5. Sorry. 7, 5, 3, and 1 are all congruent. 8, 6, 4, and 2 are all congruent. Or they're going to be supplementary. 7 and 8 are supplementary, 7 and 6 are supplementary, 7 and 2 are supplementary, 7 and 4 are supplementary. So those are only possibilities. Either congruent or supplementary. And then because half of the choices are going to be congruent and half are going to be supplementary, that means the probability of either one is going to be 1/2. And you are asked for congruent in part C. So it's 1/2. Alright, that was the homework. You should review for your quiz. Just remembering you need to be able to name the angle pairs. You need to be able to name parallel planes, name parallel lines or segments, You need to be able to name skew lines or segments. You should be able to use parallel lines to find angle measures. And you need to be able to... I think that's everything, right? Because I already said name angle pairs. So, good luck. Let's see, one of those, and there you go. This will make everyone feel better about their quiz. Now you feel good.